How important is weather forecast for you personally?
Very important because we're having a drought at the moment, so we all must be very economical with the water in this area, certainly.
For me, it's important because of my daughter. I need to know how to dress her in the morning.
No, not at all. No, if you want to know, open the window and have a look.
If I've planned something, I want to know how the weather's going to be. As I'm a harbour pilot, forecasts are essential for me.
Our whole lives depend on the weather.
Do you think that meteorologists know enough about weather and climate? Not yet. They're still missing a lot. They know a lot, but of course not everything. And as there is constantly something new, like hurricanes, floods and snowstorms, we need to better understand weather, climate and the environment. We also need to mitigate the effects of natural disasters and to ensure a sustainable development. For this, we need satellite data and images. These images and data are provided by Eumetsat.
Eumetsat is operating geostationary satellites for the benefit of weather forecasting and climate monitoring.
The geostationary meteosats continuously monitor atmosphere, ocean and land surfaces. A total of 30 European states have joined forces in Eumetsat, Europe's meteorological satellite organization, and benefit from the successful meteosat services.
In order to complement this activity, we will now also launch polar orbiting satellites, which will give even more higher details than the existing satellites, however less frequently. And these polar orbiting satellites will contribute to weather forecasting, climate monitoring and environmental studies in a unique way with very advanced instrumentation, so that the European population and the European policies can benefit from these new data sources in the future.
The new METOP satellites pass close to the poles at a height of approximately 800 kilometers to gather detailed information on atmospheric conditions. So far, the service from polar orbit has been exclusively provided by the American agency NOAA.
I'm very excited about the partnership between Eumetsat and NOAA and the benefits that we can both achieve through this partnership. Both Europe and the United States will be able to provide data from these polar orbiting satellites, both through the METOP program of Eumetsat and the NOAA Polar program.
The METOP satellites were developed by the European Space Agency ESA on behalf of Eumetsat. They carry a set of 11 new instruments, among them YASI, ASCAT, GOEN-2 and GRASS, which again were developed using the research and development skills of major European agencies like ESA and the French space agency CNES. At the same time, Eumetsat provided the MHS instrument, which is already flying on board NOAA-18. METOP satellites will also have 3 proven American instruments on board. One instrument in particular symbolizes technological innovation, YASI.
The infrared atmospheric sounding interferometer, the YASI instrument developed by CNES, the French space agency, is an excellent example of innovative, advanced European technology. It provides precise measurements of atmospheric moisture and temperature at an unprecedented accuracy and at high spectral resolution. With this, numerical weather prediction will be considerably improved through the assimilation of these data into the forecast models. More than 8,000 channels are provided by this instrument, and it's the first time that this technology is used operationally in space. Likewise, the YASI instrument will also support climate monitoring. The YASI instrument can monitor the total columnar amounts of some key trace gases like ozone, carbon dioxide, methane and N2O, and hence provide knowledge and improvement of our knowledge on atmospheric chemistry.
Throughout the orbit, these measurements are recorded on board the satellites and then are dumped over the pole. And to this effect, within the EPS system, we have built a station in Svalbard at 78 degrees north, which is at the ideal location to capture all the data acquired by the satellite. The data from Svalbard, which is the name of the station, are transmitted to Darmstadt in this processing center here, and our products are generated. These products are then disseminated to the users via the Eumetsat system, which is the same system as we use for geostationary satellites.
The ECMWF provides basic data for weather forecasting. The ECMWF and other local centres of expertise, such as the UK Met Office, Météo France and the German Weather Service, have a need for improved global data for their models. The ECMWF is the European centre responsible for the development of numerical forecasting systems. All data processed by the centre are made available to the European Meteorological Services. To us, METOP represents a major development, since its main benefit is indeed the improvement of numerical weather prediction. There will be 8 meteorological instruments on board, and we will use the data of all these instruments. One of them, called YASI, will have the highest importance for us. It's a new generation sounder which will allow for a more accurate analysis of atmospheric parameters. These new data are expected to improve the weather forecast over the Northern Hemisphere by more than 3 hours. YASI alone will represent about 25% of the information collected from all satellites used in numerical weather prediction systems. Monitoring climate and the environment is the second mission of METOP. Another instrument, GOM2, developed by ESA in partnership with Eumetsat, will be used to monitor the global distribution of ozone as well as trace and greenhouse gases. The Finnish Meteorological Institute leads the satellite application facility on ozone monitoring, the main user of GOM2. The data are used to derive a detailed picture of the atmospheric content and profile of ozone, nitrogen dioxide, water vapor, and other trace gases. We are coordinating Eumetsat's satellite application facility on ozone and atmospheric chemistry monitoring. The measurements of the METOP satellite will be used in monitoring the ozone depletion during the next 15 years. METOP will answer the question whether the ozone hole will start to decrease because of the ban on ozone-destroying chemicals, or whether global warming will actually increase the ozone depletion. The ozone holes in the Arctic and Antarctic regions are not the only phenomena worrying the scientists. Europe is also being affected. The METOP satellites will help to increase vital environmental knowledge. The climate monitoring SAF, coordinated by the German Weather Service, develops data which are used for the global monitoring of climate and the environment. The METOP satellite provides us with valuable new data which are of special relevance for climatology. We're now able to make clear statements about the climatic development of the polar regions. These are particularly important because they react very sensitively to any climate changes. The data we obtain from METOP and other satellites will then be processed by a European consortium, the so-called Climate Monitoring SAF, and climate-relevant information will then be made available to the users. The METOP launch from Baikonur on board a Soyuz Fregat launcher, from the same launch site that saw Yuri Gagarin off into space, is the start of a new era for the monitoring of weather, climate and the environment on a global scale. The Eumetsat polar system will help to mitigate the effects of especially severe weather and will ultimately benefit all mankind.